Friends, now we are in the 11th class of Signal and System Basics. So here there is one common data question and which has been asked in GATE 2007. So this is the common data. This is the common data for question number 43 and 44. So the data is a signal is processed by a causal filter with transfer function GS. For a distortion-free output signal waveform GS must. There are 4 options given and options are saying that provide zero phase shift for all frequencies, provide constant phase shift for all frequencies, provide linear phase shift that is proportional to frequency, provide a phase shift that is inversely proportional to frequency. So there are these are the 4 alternatives and we have to choose the correct alternative. Okay, so this is the common data. So from here to here, this is the common data. Okay, this is the common data. This is the common data. Common data. This is the common data. Okay. So now up to here, you can say up to here, from here to here, this is the common data. So for a distortion free output, suppose the output consists of fundamental frequency component and so many harmonics component, other frequency components also. So suppose the output contains fundamental component and first harmonic component. So then if we draw those those two individually, then the waveform will look like, suppose or you can say, let us take an example. Let us take an example of a signal. Let us take an example of signal which contains fundamental frequency component as well as first harmonic component. Fundamental frequency component as well as first harmonic component. Okay, so the signal will be like ft equal to, suppose a sin omega t plus b sin 2 omega t, because this is the first harmonic component and this is the fundamental component. Okay, so if we draw the graph, then it will be like, this is the fundamental component. Okay, so this is the fundamental component, and if we draw the graph for this component, suppose this is time t, let me denote this is time t. Okay, and this is suppose this is f1t and this is f2t. Let me write here, this is f1t, this is f1t, let me denote this is f1t. Okay, and this is f2t. Okay, and now so this ft consists of 2 components, f1t and f2t, and this one is f1t. Okay, now let us draw the graph for f2t also. So what will be the graph for f2t? Let me draw it by green or blue, so it will be more clear. So the graph for f2t will be nothing but it will be like Okay, so it will be like this. Now it is clear that suppose if we do a phase shift, this is the graph. Let me name it first. This is F2T. Okay. Now it is clear from figure that if we do a phase shift of suppose theta degree in F1T, and if we do the same phase shift in F2T, then in time domain that theta, if we suppose do the phase shift of theta degree in time theta degree for both. Okay, so let me draw another graph. So after phase shifting of phase shifting of theta degree for both, shifting of theta degree or for both, or you can say suppose we are doing phase shifting of you can say pi degree, pi radian for both F1T and F2T. The graph will be as so. Now the graph will be, let me draw the graph again. So the graph will be like, suppose this is the graph, so this is T, okay, and now now we are doing the phase shifting of pi degree, okay, pi. So the graph F1 will start from here because its pi is here, okay, its pi is here. So F1 will start from F1 will have its 0 at here, okay, means I mean suppose we draw it like let me denote it right clearly. Suppose like this, okay. So now what will happen? Now the graph will be like, so this will be the graph of F1T, okay. So this will be the graph of F1T. So now after shifting of pi radian, or you can say 180 degree, the graph will be, this part will move here, okay. So this one is the graph for F1T, okay. Okay. Now suppose if we do the same phase shift here for a graph F2T, so 180 degree for F2T is nothing but this much. 180 degree for F1T is this much in time domain, and 180 degree for F2T is just half. Okay, so this part will move here. Okay, so now if we draw the graph, it will be like let me draw by blue. It will be like, now we can clearly see, it will be like this. Okay, now we can clearly see if we add these two, if we superimpose these two graphs, then what result we get? The same result we should obtain by shifting also with But here we can see that this is the graph. This is okay. This is same this is same as previous one. But for F2 for F1t, this is F2t. Let me write here. This is F2t. This is F2t. Okay. This is F2t. Okay. So this is F2t after shifting, but this is F1t after shifting. Let me write here after shifting also, because after shifting, and this is F2t after shifting. Because this is not F2t, a term must come which is responsible for shifting. So this is F1t and this is F2t. Okay. So if we add these two graphs, or if we superimpose means if we add, then these two the addition of these two graphs must give the addition of these two, but it is not true, because this is same, but here whatever we are getting with a graph F1, that we are not getting with F2. Okay. So we can say that the graph will not be same if we shift if we shift with the same angle as we are shifting with here in both F1 and F2t. So what should be the shifting? If suppose if we shift proportionally, suppose if we are shifting this is suppose this is the fundamental component, and we are shifting the fundamental component by pi. Okay. Then this part must come here. This part must come here. Then we can say, okay, our graph has shifted and our graph is same. Our graph is distortionless. So to shift this part here, F2t must be shifted not by pi, by 2 pi. Okay. So if we shift F2t by 2 pi, then the graph will be same as the previous one. Okay. It will only reflect the shifted in time domain, but the nature of graph will be same. Okay. So if we are shifting the fundamental component by pi, then we have to shift the first harmonic component by 2 pi. Okay. So in conclusion, we can say that here I have just taken one example. Suppose the graph is the function is containing, or the signal is containing so many frequency components. So we have to shift each frequency component proportional to their frequency. Here the frequency is omega and we are shifting by pi. So here if the frequency is 2 omega, so we have to shift it by 2 pi to make the graph the signal distortionless. So if it could contain third harmonic also, then we have to shift that third harmonic by 3 pi. Okay. So now for a graph to be distortionless, for a signal to be distortionless, each frequency component contained in that signal must be shifted by must be shifted proportional to their frequency. Okay. So which of the given option is correct? So provide linear phase shift, provide linear phase shift that is proportional to frequency. Okay. This one, the option number C is correct, because other options are provide zero phase shift for all frequency. So if you are providing zero phase shift, then the graph is same. So there is nothing that we are not shifting. Another one is provide a phase shift that is inversely proportional. That is also not correct. Not inversely proportional. Other option is provide a constant phase shift. If we are here, we have provided constant phase shift. Then we can see that graph is not same. Okay. So we have to provide a linear phase shift that is proportional to the frequency. Okay, so the option number C is correct one. The next question is Gz equal to alpha z inverse plus beta z to the power minus 3 is a low pass digital filter with a phase characteristic same as that of the above question. If there are 4 alternatives given, and this question has also been asked in GATE 2007, and the same data will be used, same data means as above. Here it is given that with a phase characteristic same as that of above, means for a distortion free output, whatever is the phase characteristic, that will also be applied for question number 44. So that's why I have not erased the question number 43 because the same characteristic used for question number 44 also. Okay. So here question number 44 is, it is given that the value of Gz, the digital pass filter, low pass filter Gz is given that Gz equal to nothing but it is alpha z to the power minus 1 plus beta z to the power minus 3. So if we replace the value of z by e to the power j omega, because what is z is nothing but e to the power j omega in frequency domain. Okay, so we have to replace here z by e to the power j omega. So replacing z by e to the power j omega. Okay, we get what will be g e to the power j omega, e to the power j omega. Now g e to the power j omega will nothing but it will be alpha e to the power minus j omega plus beta e to the power minus 3 j omega. Okay, so now if we take e to the power minus j2 omega as common, then it will be e to the power minus j2 omega, then it will be nothing but alpha e to the power j omega. Okay, it will be alpha e to the power j omega plus beta e to the power minus j omega. Okay, so now the signal to be distortionless after passing through Gz, after passing through this low pass filter, all the all the frequency component must be shifted proportional to their frequency. Okay, all the frequency component must be shifted proportional to their frequency. So this is only possible if this is proportional to frequency, because here all the frequency components are shifted by here this is the frequency component, all the frequency components are shifted twice to their frequency. Okay, because e to the power minus j2 omega is with here, but this is not proportional, because alpha e to the power j omega plus beta e to the power j omega is associated with it. Okay, so if alpha, so what should be the condition so that all the frequency component must be shifted according to their frequency. And here one more thing is given. This is a low pass digital filter. So it is also given that this is a low pass digital filter. So low pass digital filter means a higher frequency component must be eliminated. Okay, so higher to eliminate higher frequency component, mod gj omega must be 0 for omega tending to 0, omega tending to infinite. So there are two conditions. At first it is a low pass filter, so for this filter to be a low pass filter, for this filter to be a low pass filter, for g e to the power j omega to be a low pass filter, okay, so it to be a low pass filter, mod g e to the power j omega, this must tends to 0, this must tend to 0, this must tend to 0, okay, when omega tends to infinity. Okay, when omega tends to infinity, so this must tend to 0. So let me check how, when it is possible, mod g e to the power j omega will be nothing but it will be mod e to the power minus j 2 omega into mod alpha e to the power j omega, okay, plus beta e to the power minus j omega. Okay, now the magnitude of e to the power j omega, this is always 1 because this is nothing but cos 2 omega plus minus j sin 2 omega, and if we evaluate the magnitude, its magnitude, then it will always be 1. So this is nothing but this is 1. So all things are depending upon this. What is the magnitude of this? Okay, so now we can see as omega tends to 0, so this is always 1. So now we can write here this will be equal to nothing but magnitude of alpha e to the power j omega plus beta e to the power minus j omega. Okay, so if we put e to the power j omega as cos omega plus j sin omega and e to the power minus j omega as cos omega minus j sin omega, then it will be nothing but alpha cos omega plus j sin omega, okay, and here plus beta cos omega minus j sin omega. Okay, so if we take the real part and imaginary part, if we separate those parts, then it will be alpha cos omega here, and this is beta cos omega. So here it will be alpha plus beta, okay, cos omega, and here it will be plus j alpha minus beta sin omega. Okay. Now suppose omega tends to infinity. Okay, so if omega tends to infinity, here it is given that this is a low pass filter. Okay, so if this is a low pass filter, so this only means that if omega tends to 0, then this must be, if omega is this is low pass filter, then if omega tends to infinity, then it must tend to 0, and the other characteristic is it must allow all the low frequencies. Means if omega tends to 0, then this must be equal to 1, or this must allow all when omega is tending towards 0. Okay, so when it is possible, if omega is tending towards 0, okay, if omega is tending towards 0, then this will become 0. So this component is showing the high pass filter property, because if omega tends to 0, then if for low frequency, if this is becoming 0, so this is only showing the high pass filter property, and if omega is 0, then what will be this? What will be this part? This part will be alpha plus beta cos omega will be 1. Okay, so frequency component will just got out, means there will be no frequency component. So this is only possible when alpha is equal to beta. If alpha is equal to beta, then this part will, the imaginary part will be 0. Okay, the imaginary part will be 0. Only we are left with the this real part. Here also there are 4 alternatives. If alpha equal to beta, so if alpha equal to beta, then the imaginary part will be 0. If alpha is minus beta, then imaginary part will be there. Okay, if imaginary part will be there, then the omega component, then the omega component will also be there in amplitude, and this will not correctly represent the low pass filter, because this is the component for high pass filter. Okay, and others are also for others alternative it that also apply. So if alpha is equal to beta, then only this part will vanish out, if alpha equal to beta, and we are only left with this part. Okay, so let me write this. If alpha equal to beta, then mod e to the power mod g e to the power j omega. Okay, this must be equal to how much? Alpha plus beta cos omega. Okay, so if alpha and beta both are equal, then this will be equal to 2 alpha cos omega. Now we can clearly see, as we increase the value of omega, okay, as we increase the value of omega, this part will reduce, because the value of cos omega will decrease. It will be maximum for omega equal to 0. So we can clearly see that this filter is passing low frequency only. As we are increasing the frequency, this filter is the value of 2 alpha cos omega is decreasing. So it is satisfying the property of low pass filter. Okay, and again the frequency has got shifted by minus 2 j omega, which is minus 2 j omega means here minus 2 omega. Okay, so frequency has also got shifted proportional to the frequency of frequency component that is contained in the signal. So frequency will be distortionless. So now if alpha equal to beta, then mod g e to the power j omega will be 2 alpha cos omega, and we can write from here, angle g j omega, g e to the power j omega. Okay, g e to the power j omega, that will be nothing but the angle part will be minus 2 omega. Okay, so angle is also angle also gets shifted proportional to the frequency, and this represents the characteristic of low pass filter, because for omega equal to 0 the value will be maximum, and as we increase omega the value will decrease. So option number A is correct one. At the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe the video, so that there is no need to search the new video which I upload. The automatic upload will come to you. What you have to do for this? It is very simple. There is a circular logo containing my photo is coming in right of me. You have to just click on that for subscription.